Okay, we're looking at question 6 from the 2010 exam 1, which is by hand. So this question involves transformations using matrix formats. So here's the matrix transformations that have taken place. The image of the curve, so the original equation is this, and the image is just a fancy word for what's the equation after the transformation has taken place. So we have to find the new equation after this transformation has taken place. And we need to make sure it's in this type of form so we can find these coefficients A, B and C. So basically here's our equation that we need to start with, and first of all what I'm going to do is I'm just going to rewrite it as x dash and y dash. The dash is just a way of saying that's the coordinates for the image, or the x and y value for the image, the new equation, and we'll rewrite the rest of it as well. Okay, so there we go. And so what we're going to do next, we're going to expand out the matrix. So 3 times x and 0 times y. Take that row and multiply it against, take that row, multiply against this column. So we've got 3x and plus -1, so it's just -1. And that's the first row, so that's x dash we're finding here. X dash equals 3x minus 1. And y dash is equal to 0 times x and 2 times y, so 2y plus 4, okay, plus 4. Alright, so what we need to do is actually transform these equations to make x and y the subject. The reason why we need to do that is because we're going to substitute that back into the original equation, so we can then find the equation of the image. Okay, so the next step is basically just to transform this equation to make x the subject. So I'll just do it quickly. We need to move this 1 to the other side of the equation, make it plus 1, and then we would divide by 3, right? So if I did that, I'd have x equals x dash plus 1, x dash plus 1, and then divide by 3. And for this one, second equation, we have y equals, we'd move the 4 to the other side, so we'd have y dash minus 4, and then we'd have to divide by 2. Okay, so there's our two equations in the form of x and y. We're going to substitute these values back into the original equation, and that'll give us the new image. Okay, so instead of y, we're going to write y dash minus 4 over 2 equals 2, and instead of x here, we're going to write x dash plus 1 over 3. It's all squared plus 1, so replacing x with all of that. Okay, so all we have to do then is, there's our equation, there's our new equation after the transformation's taken place, but we need to get it into this form. Okay, so we're going to have to expand all this out basically and make sure it's in this form. So that's okay, we can do that. Okay, so what we'll do first of all is we're going to move or multiply both sides by 2. Okay, so if I multiply by 2 here, it gets rid of the 2, multiply this by 2. Instead of rewriting it, I'll just put it in brackets and put a 2 at the front here. Okay, 2 times all of that. And then I need to add 4. Okay, so add 4 to this side of the equation, the negative 4 will disappear, and plus 4 over here. Okay, that's fine. Next thing is we need to expand out this x plus 1 over 3 squared. So what I'm going to do is change that to x dash over 3 and then 1 over 3, and that's basically squared, so it's times itself, x dash over 3 and 1 over 3. And the rest of this all stays the same. Okay, so plus 1, then a bracket, then plus 4. Then over here there was a 2, and then there was a bracket, and then there was another 2. Okay, so all I did was expand that out. Okay, so I'm just going to move up to here now, and the next step is I need to multiply this bit out. So I'm just going to rewrite the 2, and then a bracket. So we've got x dash times x dash, that's x dash squared. And we've got 3 times 3, which is 9. And then we've got x dash times a third, which is x dash over 9. We'll have another x dash over 9 as well. So basically we've got 2 x dashes over 9. 2 x dash over 9. And then we've got 1/3 times 1/3, which is plus 1 over 9. And then it's plus 1, and then it's plus 4. Okay, we're getting there. What can we do next? Let's multiply everything by 2. In fact, 2 times x dash squared over 9 plus 2 times that is 4x dash over 9 plus 2 over 9 brackets, and we got another this 2 here, and we got plus 1, then we got plus 4. Okay, so we've got to multiply by 2 again, so that's 4x dash squared over 9, and 2 times 4 is 8x dash over 9, and 4 over 9, and 2 times 1 is 2, plus 2, and then plus 4. Okay, we're nearly there. Okay, we're nearly there. Okay, so we've got that a is the coefficient of x squared, so a is 4 over 9. Yeah, coefficient of x squared, a equals 4 over 9. We've actually got the b value as well, because that's the coefficient of x, 8 over 9. So b is 8 over 9. And the only thing we're missing here is c. C is all this stuff here. Okay, so we just need to basically find that out. So we've got 2 plus 4, which is 6, and 4 over 9. Okay, so we could write it as c equals 6 and 4 over 9. That's fine. But you might find out on the assessment report it's put it as a whole fraction, so 6 times 9 is 54, 58 over 9. Okay, so there's our solutions. It's worth 3 marks, so a little bit involved there. Okay, so that's basically how we do it. Let's have a look at the assessment report. So we're looking at exam 1 2010. Oops, back to that. Exam 1 2010. And okay, so we got our right answers. A is 4 over 9, B is 8 over 9, and 58 over 9, so that's all good, and that's fine. So there are 3 different approaches we're taking to this question. Students who attempted to define the transformations often misinterpreted both dilation and horizontal translation, then did not rearrange to construct a new rule. Students who choose to determine the inverse matrix often made errors. So basically just saying there's a few errors there. What was the average out of interest? Out of 3 marks, 1.2 was the average, so not done too well. Now I did mention 3 different types of methods to do this. I chose the method that I've shown you here, and this is probably the safest method. You could have also had a go at doing this. You might have noticed from the original matrix that this 3 is a dilation from the y-axis of factor 3, and for y it always replaces x with x over this number, x over 3. So in the equation we've replaced x with x over 3. Okay, the 2 is a dilation from the x-axis, and that always goes on the outside of the function, so that's the 2 there. And the negative 1 transforms the graph to the left 1, or translates to left 1 along the x-axis, and that's what this is doing here. You remember we changed the sign around, and the plus 4 moves the graph up 1, so that's this bit here. So you could have a go at putting all these values into the equation directly, but it does leave yourself open to mistakes because the order of these transformations are important. So this is the very safe method to do it, so it's probably the one that you need to practice the most. Okay, good luck with that.